Okay, back to the Flargak now. A four-sided shape with two congruent adjacent sides. So that's the next one that we want to draw. So I would, which shape? Okay, joined by a right angle. So for me, I could go like that and go like that. Here are my two adjacent sides that are equal. And then I could just kind of draw out to here and to here. This has to be a 90. And be careful not to make a kite when you do this. But since this is a different distance than that, I've now done that. Now it says stretch two distinct Flargaks on the grid. In one Flargak, avoid letting each side be horizontal or vertical. Well, that's what I did in the last one. So on this one, we can't have these two sides be vertical and horizontal. So I'm going to create one side that has a slope of 2, and then the other side would have to have a slope of -1/2. So we'll call this A, B, C, and that has to make a 90 because this is 2 and this is -1/2. And then I can just kind of go like this for the other ones. Okay, let's get on to some more difficult problems. I don't think there's too much Flargak business on the real test. Okay, 6, sketch 2, I guess, no, we did that one. 7, good, I was done with Flargaks anyway. Consider the diagram to the right. Answer the following questions and show how they work to justify your answer. Find the circumference of the circle. So for circumference, the formula is pi times the diameter. So that must mean that I need to get the distance all the way across the circle. So in order to do that, I am going to, I could do some Pythagorean theorem and try to get like that diameter, which I might have to do anyway. So let's just solve for this radius, because that's going to help us later anyway with the area. So to do that, I would make my right triangle, and this is 2, and this is 1, 2, 3, 4. So the radius would equal 4 squared plus 2 squared is c squared, and then I would have 16 plus 4 is c squared, and the radius would equal the square root of 20. And the square root of 20, I'm using my phone to record these videos right now, so I don't have it to use as a calculator, but I can estimate that the square root of 20 is going to be about 4.4. You can check that with your calculator to see if it's right. It's definitely close enough for our purposes. So this is going to be equal to, actually I did check it, it's 4.5. This is going to be equal to 4.5. So that means the diameter has to be 2 of those. So the answer is pi times 9. And the circumference is 28.26. Okay, find the perimeter of the triangle again. Okay, we just did this, but we are going to do it again. So for this one, we are going to get the lengths of the 3 sides. So quickly sketch this one, which is a 2 by 1, 2, 3, 4, 5, 6. So ED, you could do it here, ED is equal to 2 squared plus 6 squared is going to equal c squared. And then we have 4 plus 36 is c squared. So basically the square root of 40 is c squared. And I'm going to write the square root of 40 as 6.3. So there's one of my 3 sides. Now I need to get the other 2. And luckily for us, BD is real easy. I love when it's vertical because you can just count 1, 2, 3, 4, 5, 6, 7, 8. And now the only thing we have to do is solve for EB. So I make my triangle like this. I would say the #1 skill you're going to need for this test is finding the lengths of segments on a grid by using the Pythagorean theorem or the distance formula. So these go by 2s, so to 10 to -2, this distance is 12. And this distance would be 4 to 16, which is going to be equal to 12. So 12 squared plus 12 squared is equal to c squared. So we have 144 plus 144 is equal to c squared. And then we have 288 is equal to c squared. So c has to equal the square root of 288, which is let's see here. I don't have my calculator with me, and I'm using my phone for that. So I'm trying to do this in my head right now, but maybe on your calculator, you guys could figure it out right now. I think it is about 17. So whatever it is, let's say that it is 17. We would now take that side plus the 8 plus the 6.3. And that would leave me with 31.3. As we're doing this in class, I'll probably have you guys pause the video and get that exactly, and that might slightly alter this answer here. Okay, we can quickly find the area of the circle not contained inside the triangle. So if the triangle has an area of 31.3, and that's the triangle, we would need to go circle, take away triangle. So I know that this is 31.3. I just need to get the circle area and then subtract 31.3 to give me my answer. So the area of the circle, remember we calculated up here that the radius was 4.5. So the circle area must equal pi times 4.5 squared. So the area of the circle is 63.6. So I would go 63.6, take away 31.3, and the answer is going to be about, again, I don't have a calculator, so we're going to compute that in class and then just write the answer to that right there. And that will be the area of the circle not contained inside the triangle.